In this video, we will find the buoyant force on a 0.2 meter cube of cherry wood in water. I specified cherry wood because different types of wood have different densities, and cherry happens to be one that's in our textbook. So I was able to look up the density of cherry wood in our textbook. So 800 kilograms per meter cubed. Water we know is 1,000 kilograms per meter cubed, and the length of each side of the cube is 0.2 meters. So what's going to happen when you put this cube into water? The density of the cube is less than the density of the water, so that means it's going to float. So the water level will be, I don't know, somewhere in the middle of the cube. So the water is here. We're looking for the buoyant force. So buoyant force is rho of the fluid times G times the volume displaced. Okay, when we looked at an aluminum cube in water, it was really easy to figure out what the displaced volume was. This time it's not so obvious because the displaced volume is how much water had to be pushed out of the way for this block of wood. And it's not the volume of the wood, because all of the wood's not in the water. It's floating. So that's actually not a good way to look at it. The best way to find the buoyant force on an object that's floating is actually to draw a free body diagram. So we go back to Physics 1 for this. So the free body diagram of this thing, I have the weight, the gravitational force, pulling down on it, but it's floating up there, right? There's some other force that's pushing it up. That is the buoyant force. Okay? And those are the only forces that are acting on it. And I know that the sum of the forces on something, so the net force, is equal to the mass of the object times the acceleration of the object. What's the acceleration of a block that's sitting there floating on water? It's not moving at all, right? It's no velocity. The velocity is not changing. Since the velocity is not changing, the acceleration is zero. So the net force has to be zero. That means the sum of forces, that's FB in the positive direction, this has to be zero, minus mg, because mg is pointing in the negative direction. That means the buoyant force is equal to mg, the mass of this block, times gravity. So the mass of the block, we aren't given it, but we know the density, and we know that density is mass per volume. So mass must be rho times v. So this is rho v g. So 800 kilograms per cubic meter times 0.2 meters cubed times 9.8 meters per second squared. So that's 62.7 newtons.